Hey guys, let's go to problem 27, okay? So 27, here we go. So we got f of x, which is going to be f of x, which has to be the usual function x squared. We subtract it with the floor part of it, so we get the decimal part, right? And we're getting some g of x, right? So we get g of x out there. So g of x equals 1/4 of x squared. Okay, so what do we get? We need to find the number of intersections. And I would say we need to be able to graph what this function is. So here's what we're going to do. I'm just going to sketch some parts of f of g of x. Okay, so I'm going to sketch f of g of x. So that will be my, this will be my x-axis and this will be my y-axis. And we're going to find out what will happen if it's starting from 0 and we hit 1. And let me say that becomes also 1, I would say. And we're going to find out what will happen if I plug 2. Okay? If I plug 2, well, you can check that with lots of ... We're going to find out some y value of 4, right? So we get all those values. And when you see some floor functions, you always got to think in terms of the integer intervals. So we usually cut everything into the floors. Okay, so everything that stayed in between 0 and the first floor, the y equals 0 and y equals 1, if you put the floor function like this, well, eventually that becomes, let me change the color of it, okay? So if I change the color, it becomes somewhere down there, okay? All right, so that's the shape of this, the floor function part. Okay, so what will happen for, the stuff that are staying between 1 and 4? Well, I told you we got to cut it out into, like we got to cut it out with each floor. So we get the first floor and we get the second floor and we get the third floor and we get the fourth floor like this. So we get the second floor and the third floor. Everything that stays in the first floor and the second floor, this portion out there, is going to be always going down to the first floor, the bottom of the first floor. So I'm going to switch this color into the red one, and that will be something about this much. Right. So what about like from the second floor and the third floor? The portion that actually went up in between the second floor and the third floor, the spike that you see down there, it's going to be actually someone's going to pushing it down all the way down to the bottom of the second floor. So we get the these black portion, the spike actually gets smashed down all the way to the red portion. And you can also check that in the third floor and the fourth floor, the spikiest one, the highest peak that you see will actually eventually get, all smashed down, right, onto the third floor. So we're going to take out the difference between those x squared, the black curve, and the red line segments, so to speak. So if I sketch this graph portion out there, well, you can check that in between 0 and 1, there's only going to be one portion of the curve. But you can check that up from between 1 and 2. These portions that you see as, let me change the color. I'm not sure whether you guys can see this, but this is going to be a pink. The portions that you see right there, it's going to be falling down all the way down this much. And the portion that you saw here is going to fall down, and it's going to be colored all the way up to 1, I would say. So all the way up to 1, and you can see this portion out there. So also going to be falling down, and it's going to make that much edge. So you can see that you can imagine you playing Tetris. So if you push push the enter bar or the space bar, well, those portions actually fall down all the way down to the earth. And you can also see that much portion is going to fall down all the way onto the ground. You can see that portion is going to fall down. So we get in between 1 and 2, we got 3 spiked curves that are cut into 3 pieces and are all like coming down to the ground. And what can you imagine? What can you imagine, about the behaviors of those graphs in between 2 and 3? Well, I would say we got 1 curve and there's going to be 3 curves. So probably it could be 5 curves. And it is true, it is true. All right, so imagine graphing f of x. Now, if I graph f of x, well, I would say graphing f of x wouldn't be that bad. So here we go. We can graph this portion out here from this much and about the 3 curves that goes like this. So I can say this is 1. I can say that these are 2. And that's going to be 1 as well. And there's going to be extra portion of the graph. And of course, these are all even function. So because these are all even function, you can check that at -1, we're going to have the even function type, and we're going to have these spikes, the 3 spikes that we saw in between 1 and 2. It's going to be reiterated in the reverse manner, or somehow reflected manner, in this type of shape. Okay, in these shapes. All right, and you keep graphing all the other portions. Now, imagine what's going to happen if I sketch 1/4 of x squared. So if I sketch 1/4 of x squared, let me use different colors. All right, so the pink will be fine. So if I use different color, well, you can check that it's going to pass through like this. It's going to pass through like this. All right, so it's a bad curve. It's a bad drawing, but you can still see what's happening out here. There's no intersection between the pink curve and the last edge that you saw there. Why? Because at x equals 2, we get 1. So g of 2 equals 1. So we know that it's going to pass through 2, 1. So it does pass through g of 2 equals 1. And at the same time, g of -2 equals 1. So we know that's going to happen. Now, how many intersections can we find? We can find 1 point of intersection, another point of intersection, and the common point between the usual curve, I would say, the y equals x squared, and the y equals 1/4 of x, 1/4 of x squared, and we get extra 2 points of intersections. So how many points did we find? Like 1, 2, 3, 4, 5. So the answer for our question must be 5, and that shall be it.